Today we are talking about atoms bonding in the periodic table. I'm just going to run through a couple of things real quick, going through this section of this book that I found that would be useful. This is pretty much the last section in our periodic table unit. So it was a short unit because we had to add some more things onto it. But the pretest that you took, we already know that means a post-test will be coming next week. So once you finish up with this agenda, the last thing on the agenda actually is working on the study guide. So I'm going to run through some information in here real quick and then just kind of give you some key points, reading through some things that are important so that you know, just having the last little bit of information. So we talked about in the other video as far as what a valence electron is. And we know that a valence electron is just saying that it's those electrons that are on the outermost shell. Now, the valence electrons, this is important here, those are the electrons that have the highest energy. Valence electrons are involved in chemical bonding, as we said. Key point here, the number of valence electrons in each atom help determine the chemical properties of that element. And that's what, we kind of mentioned in some of the videos and things, as well as the other one when we talked about making our Bohr models. You have like the 2 and et cetera, and, and going on from there. So like this would be 1, 2, 3, 4, 5, 6. This would be carbon. But those valence electrons, the fact that it has 4, it tells me, what kind of bonds it will make, who it will bond with. So I'm skipping down. We don't really need the electron dot diagrams. You probably will learn that more in high school. It's just another way of showing those valence electrons. But key things, this whole section here, that atoms tend to be more stable. And you want them to be stable. Think about if you're stable versus if you're not stable. Atoms tend to be more stable if they have 8 valence electrons. It's a complete set. If you look at, you want it to have 8 on the outside. So this one would be neon because it has a total of 10. Neon is stable. As it says, atoms of neon, I'm right here. Atoms of neon, argon, krypton, and xenon have 8 valence electrons. These elements are non-reactive or stable. And if you look on your periodic table, they are known as those noble gases. So helium is kind of the exception. It's stable with its 2 electrons. So atoms tend to form bonds so that they have 8 valence electrons and become more stable. The goal is to become stable. If they're stable, they're happy. Where was I? Hydrogen needs only 2 to be stable. When atoms bond, valence electrons may be transferred from one atom to another, or they may be shared between atoms. And when we start talking about bonding in the next section, we'll talk about the specific types of bonds, and that'll be a matter of if they're transferring, meaning like they're losing one or gaining one, or if they share one. But a chemical bond is the force of attraction that holds atoms together as a result of the rearrangement of electrons between them. So this is kind of the gist of what you need so far. Like I said, in the next section, we start talking about bonds, the actual chemical bonds. We have these things called like ionic and covalent bonds that we'll get further into, but I won't talk about it too much now. So when we talk about those noble gases, that's this row here. The noble gases are the most stable. They're the least reactive. They're happy. They're not reacting to anything because their whole life is complete. Think about those people, and they're not reacting to everything because their life is complete. These people, or these elements, are complete, and so therefore they don't have to be worried about everything else. Now, on the other hand, when we start looking at these metals over here, like these alkali metals and these alkali earth metals, these are the alkali earth metals, these are alkali metals, then, these are more reactive. They're trying to get to where the noble gases are. So it's just a matter of like, I only have one electron to lose and I can be perfect. So I'm most reactive. Think about when you're angry, some of y'all, and you're like, oh my gosh, I only got one more thing to set me over. They only have one electron to lose, but then they'll be happy. So skimming down some more. So I'm just running through some of these, and feel free to jot some of this stuff down as you're studying, preparing for your test, working on the study guide. Because I'm just talking about those different families of elements. Like we said, we have our noble gases, we have our metals, which is most of these are metals. It's just a matter of what type of metals. Then we have these, that are our metalloids. And then these are all our non-metals. So, and including that one. Now, skimming back. So, like it says, the noble gases, I'm here, are in that group 18. So they have 8 valence electrons except for helium, which has 2, but it's still stable. Atoms with 8 valence electrons, or in the case of helium is 2, they are stable. They are unlikely to gain or lose electrons or to share electrons with other atoms because they're already set. They said, no, I can't get rid of any or gain any because I'm perfect. So noble gases do not react easily with other elements. That's important. Some don't react at all, but chemists have been able to make some noble gases form compounds with other elements. So key thing out of noble gases, they're not reacting to anything because they're already set. They're already happy. They don't need to be stabilized. Now, metals, on the other hand, metals is the most of the periodic table. So metal atoms react by losing their valence electrons. In general, the reactivity of a metal depends on how easily it loses, its atoms lose valence electrons. The reactivity of metals decreases from left to right across the periodic table. So if we look back at the periodic table, as we're going from left, change colors. If we go from left to right, these are the most reactive versus these are the least reactive, which would make sense. If we just said that the gases over here, they're the complete least reactive, then the opposite end, these are the most reactive. These need less, there's nothing just to lose or gain an electron, and it'd be a different thing. So let's see, that's important too. As far as the left side of the periodic table, the alkali metals, each alkali metal is the most reactive element in its period. So it's the most. If you're comparing the periods, meaning, the ones going left to right, the one, the alkali metal, which is on the end, that first column, the ones on that end, that family of alkali metals, it is the most reactive. Atoms of the alkali metals have 1 valence electron, except for lithium. When a group 1 atom loses an electron, it is left with a stable arrangement of 8 electrons in the highest energy level. So these electrons are in a lower energy level than the 1 valence electron that was lost. So the alkali metals are so reactive that they can cause an explosion when added to water. So main thing, alkali metals, most reactive out of all of them, pretty much. They will be the ones to lose an electron. Now, when we talk about nonmetals, with nonmetals, the elements, those are the ones closest to the right side of it. Nonmetals become stable when they gain or share enough electrons to have 8 valence electrons. So that's important here. That's my dog. So hydrogen atoms are left with a stable arrangement of 2 electrons. And for example, when you see like the, like oxygen, oxygen, and then it has 1, 2, 3, 4, 5, 6. It's actually shared. This is hydrogen. And that's hydrogen. So a better example, it's supposed to look like a Mickey Mouse, except I drew my circles a little off, but it essentially looks like that. And that's why they call it the Mickey Mouse molecule. Because as you can see, the electrons are shared. Hydrogen already has the 1. This is hydrogen. And oxygen has those, they have the 6 on the outside and the 2 on the inside. So it ends up looking like a Mickey Mouse. So, and that's a matter of combining those nonmetals. Back to that point. So when we talk about their sharing, that's what happens with water, as that's a common one. It's because those electrons are shared, and that's how we have H2O. Yay! So the nonmetals usually combine with metals by gaining electrons. Nonmetals can also combine with other nonmetals and metalloids by sharing electrons. That's all important. Now, atoms of group 17, the halogens, has 7 valence electrons. And when we talk about halogens, that is this row right here, starting with fluorine and all of that. Fluorine, chlorine, and so on. So a gain of 1 more electron gives these atoms a stable 8 electrons. So the halogens react easily with other elements. So that's important too, those halogens. Last 2 points real quick. So metalloids, that's that zigzag line through the periodic table, they're pretty much like the mixed ones of the periodic table. They have some properties of metals, some of nonmetals. So atoms of the metalloids can either lose or share electrons when they combine with other elements. So they may lose or share them. Each metalloid has some of the properties of metals and some of the properties of nonmetals. Metalloids, properties of both. And lastly, hydrogen is placed in group 1 in the periodic table because it has 1 valence electron, which would make sense. But hydrogen is considered to be a nonmetal. The properties of hydrogen are very different from the properties of the alkali metals. Hydrogen shares its electron when forming compounds with other nonmetals to obtain a stable arrangement of 2 electrons. So just some questions while you're thinking about it. Make sure you know what valence electrons are. How do they change? How do properties change as you go across a period? And what things are in common when you're talking about groups? What is the reactivity like as you go across a period? What do you think the reactivity is like if I'm comparing different elements in the same group? So these are all things to think about. This is pretty much it. Like I said, this is it for periodic table. I will upload this too if you just want to go back and look at it. But the video's here, but I'll also upload this actual PDF with me scribbling on it as well. If you have any questions, please feel free. Please do, message me, email me, something, reach out if you have any questions. But like I said, watch these videos, practice these things. See if you have any questions, work on that study guide because your test is next week and I don't want y'all cheating on it. So therefore try to learn, make sure you have the stuff so that you don't have to cheat on it because somehow I will know. So that is all.